Hello, this is Dr. Hanaa Assil, and this is paper 2C, January 2020. Let's take a look at the questions and discuss the answers. So the first question here says, this question is about elements, compounds, and mixtures. Name the element that burns with a lilac flame. Remember, you are required to know the results of flame tests. So which one gives lilac? You should realize that is potassium. Name the technique used to separate the mixture of colors in black ink. If I have a mixture of colors in ink, how do we separate the constituents of ink? Of course, we use chromatography. The box gives the names of some substances. Choose substances from the box to answer these questions. So he's saying identify which of these is the compound. So which one is the compound? You should realize that is sodium chloride. Compounds are made of two or more elements chemically bonded together. So sodium chloride is a compound. Identify the mixture. Which of these is a mixture? Well, from the choices, you should realize that air is a mixture of gases. Identify the non-metal element that is a solid. So you're looking for something that is non-metal and a solid. Non-metals in this list are bromine and neon, but the one that is a solid is sulfur. Crude oil is a mixture of hydrocarbons. Name the process used to separate crude oils into fractions. Remember, crude oil is separated into fractions using fractional distillation because crude oil is a mixture of liquids. Then he's saying give one use of the kerosene fraction. Remember, you are required to know the arrangement of the fractions, the order of the fractions, and the uses of each fraction. So what is the use of kerosene? You should realize that is fuel for jets. One of the hydrocarbons in the refinery gas fraction is an alkane with this formula. Give the name of this alkane. I'm going to remind you, how do we name alkanes? We said, first of all, you take a look at how many carbons. Now, how many carbons do we have here? We have 4 carbons, so the name should start with bute. And then you decide, is it an alkane or alkene or alcohol or acid? He tells me it's an alkane, and you should realize that there are only single bonds between them, so the name should end with ane. So the name of that is butane. Then he says calculate the relative molecular mass. Of course, how do we calculate relative molecular mass? We add up all the masses from the periodic table. I'm going to remind you again, the mass is the big number in the periodic table. So we have 4 carbons, each one has a mass of 12, plus 10 hydrogens, each one has a mass of 1. So the total MR is 58. One of the alkanes in the gasoline fraction has this displayed formula. Determine the molecular formula of this alkane. Of course, molecular formula means you just add up all the carbons and all the hydrogens. So how many carbons and how many hydrogens do you have up there? It is C7H16. Give the general formula for the alkanes. You are required to know what is the general formula of alkanes. It is CnH2n plus 2. So the number of hydrogens is always twice the number of carbons plus 2. Catalytic cracking is used to convert long chain alkanes into shorter chain alkanes. Name the catalyst used in catalytic cracking. You remember what is cracking? Cracking means I have a long chain and we break it up into 2. Now, what are the conditions for this? Aluminium oxide catalyst. What if he asks about the temperature? You should know that the temperature is 600 to 700 degrees Celsius. Explain why it is necessary to convert long chain alkanes into shorter chain alkanes. Why do we need to do cracking? You should realize that shorter chains are more useful, more in demand, more profitable economically. And one of the products that we usually get from cracking is ethene, and we need ethene to make things like ethanol and polymers. Catalytic cracking also produces alkenes, so he's saying I'm starting with C11H24. It can undergo cracking to give pentane, which is C5H12, and two different alkenes. So I want to put two different alkenes. Of course, we said the total number of carbons on either side of the arrow should be equal, and the total number of hydrogens on either side of the arrow should be equal. So if I took from the C11, I took C5, I am left with 6 carbons. Now he wants two different alkenes, so I need to divide them so that they are not the same. So C2H4 plus C4 H8, that will give the correct total number of carbons and total number of hydrogens. This question is about copper and its compounds, and he's saying copper is a metal used for electrical wiring. Explain why copper is a good conductor of electricity. Of course, you should realize that copper is a metal. If we say why any metal is a good conductor of electricity, because it has free moving delocalized electrons, or it has delocalized electrons that are free to move. This apparatus is used to investigate the electrolysis of copper sulfate solution with graphite electrodes. And he says copper forms at the negative electrode and oxygen forms at the positive. That is correct. You should know when we do electrolysis of copper sulfate, it is the copper that forms at the negative and oxygen forms at the positive from the reaction of the hydroxide ions. Okay, state what would be observed. He already gave you the products. So what do we see when these products are formed? So he's saying I have copper forms at the negative electrode. What would be observed? What is copper? What does copper look like? You should realize that copper is a reddish brown solid. So what we see is a reddish brown solid or reddish brown metal forming. Now, what do we see at the positive electrode? He said oxygen forms. That means I will see bubbles of colorless gas. The ionic half equation for the reaction at the negative electrode is this. State why this is a reduction reaction. Of course, here we're not talking about exchange of oxygen. We're talking about exchange of electrons. So why is this reduction? Because the copper 2 plus gains electrons. So gain of electrons is reduction. Explain why copper sulfate solution becomes paler during the electrolysis. Remember, the copper sulfate solution originally is blue, but then when it reacts, we said it forms copper at the cathode and oxygen at the anode. And what is left in solution? The copper ions reacted, so there is no more copper sulfate in solution. What I have actually is sulfuric acid. So the copper 2 plus ions, which are the source of the blue color, gain electrons. They are removed from solution to form copper metal. So the solution becomes sulfuric acid, which is colorless. Remember, the color becomes paler due to the removal of the copper ions, because it is the presence of the copper ions that causes a blue color. When hydrated copper sulfate crystals are heated, anhydrous copper sulfate forms. A mass of 12.5 grams hydrated copper sulfate crystals is heated in a crucible until all the water of crystallization is removed. So he's starting with 12.5 grams of hydrated copper sulfate crystals. So that's copper sulfate with water. Now, at the end, after he heats it, a mass of 8 grams of anhydrous copper sulfate remains, show by calculation that the formula of the hydrated copper sulfate is copper sulfate 5 water. Remember that we said in this case we get the mass of water. Of course, the mass of water is the difference between the hydrated and the anhydrous. And we already have the mass of the anhydrous, that is 8. So the copper sulfate alone is 8 grams. The water is 4.5 grams. And we're basically trying to get the empirical formula. So we divide by the MR of each one. The numbers that come out, we divide by the smallest. This comes out 1 to 5. That means that the formula is copper sulfate 5 water. A student investigates the reaction between sodium hydroxide solution and dilute sulfuric acid. He does a titration to find the concentration of sulfuric acid. This is his plan for the titration. There are some mistakes and omissions in his plan. And the first question says, give the color change of the methyl orange indicator at the end point. He says he added the methyl orange to a flask that has sodium hydroxide. So he's starting with a base. Remember that methyl orange in base is yellow. And at the end point, or when the solution becomes neutral, then the color becomes orange. Okay, this is the list that he says, and he's saying describe 4 changes that the student could make to improve his plan. So let us take a look at the plan again. What did the student do? Rinse a conical flask with sodium hydroxide solution. Use a measuring cylinder to measure out 25 centimeter cubed of sodium hydroxide solution and put it into the conical flask. This is not correct. We do not use measuring cylinder to measure the 25 centimeter cubed used in titration. We use a pipette instead of measuring cylinder to measure the sodium hydroxide solution. And then he says add a few drops of methyl orange to the flask. Then rinse a burette with water and fill it with acid. You should realize that we rinse the burette with water to remove any previous solutions. But then we have to rinse the burette with the acid that I'm going to fill it with so that there is no water remaining in the burette. So we need to rinse the burette with acid to remove the traces of water. Then he says add the acid from the burette to the conical flask until the indicator changes color at the end point of the titration. Record the final burette reading. Well, first of all, he should have said that he noted the initial reading in the burette. Before I add the acid from the burette, I should note the initial reading. And then once he did the recording of the final reading, we're supposed to repeat the titration to obtain concordant results. Remember, concordant results means results within 0.2 of a centimeter cubed of each other. Then he says the student then does the titration correctly. He finds that 16.70 centimeter cubed of the acid neutralizes 25 centimeter cubed of the base that has this concentration. Calculate the concentration of sulfuric acid. You should get used to this kind of equations because it's repeated in every exam. He gives me information here about what? I have volume and concentration of the sodium hydroxide. So that's the first thing I should do, get the number of moles of sodium hydroxide. This is a solution, so concentration times volume to get the number of moles of sodium hydroxide. Then what he wants is concentration of sulfuric acid. So I need to relate that from the equation. You can see that 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. That means the number of moles of sulfuric acid will be half of the number of moles of sodium hydroxide. Then we can get the concentration of acid, that is number of moles over volume. Remember that in all of these, the volume has to be in decimeter cubed. So we divide the centimeter cubed by 1,000 before we put it in here. And this gives the concentration of the acid in mole per decimeter cube. Oxygen can be prepared from hydrogen peroxide using a catalyst. What is a correct statement about oxygen? Remember, what was the test for oxygen? It relights a glowing split. Explain how a catalyst increases the rate of a reaction. Remember, we said the catalyst increases the rate of the reaction because it provides an alternative pathway with lower activation energy. Are we okay with all of this? Okay. Then he has this question about bond energies. So he's saying the equation for preparation of oxygen from hydrogen peroxide is this, and he writes it all out with the bonds, and he's saying use the values to calculate the enthalpy change. So of course we add up all the bond energies, and we said the reactants minus the products will give us delta H. So let us take a look at this. Before the arrow I have 4 OH bonds. So that is 4 times the bond energy for the OH. Plus I have 2 O single bond O bonds. So that is 2 times 143. So this is the energy needed to break the bonds in the reactants. Then I look at the products. After the arrow, what do I have? I have 4 OH bonds and 1 O double bond O. So that is the energy released when the bonds are formed in the product. Now, the delta H is the reactants minus the product. So this gives a total of minus 212 kilojoule per mole. Of course, if it is a negative number, then you should realize that this is an exothermic reaction. So when he says complete the energy level diagram for an exothermic reaction, that means the reactants give out heat. That means the products have lower energy than the reactants. And you have to write, if it is not written, you have to write what are the reactants and what are the products. And of course, the difference in energy between reactants and products, that is what we refer to as delta H. Ethanol can be manufactured from ethene and steam using phosphoric acid. So this is the reaction of ethene plus water in presence of phosphoric acid to get ethanol. What was the temperature and pressure of this reaction? You should remember the temperature is 300 degrees Celsius and the pressure is 60 to 70 atm. Draw the displayed formula of ethanol. Again, I'm going to remind you, displayed formula means showing all the atoms and all the bonds. F means 2 carbons. All means it has an OH somewhere, and then you complete the formula so that each carbon has a total of 4 bonds. So this is the displayed formula of ethanol. Then he says ethanol burns in a plentiful supply of air to form carbon dioxide and water. So give the chemical equation. Again, I'm reminding you, chemical equation means symbol balanced. So ethanol is usually written C2H5OH. It is reacting with oxygen. If it is plentiful supply of air, as he says, well, he already tells me it should give carbon dioxide and water, and you need to balance the equation. When the air supply is limited, incomplete combustion occurs and carbon monoxide forms. State why carbon monoxide is poisonous. Remember we said carbon monoxide is poisonous because it reduces the capacity of blood to carry oxygen. So it does not allow the blood to carry as much oxygen as it should. When ethanol reacts with ethanoic acid, an ester forms. Give the name of this ester. So here he just wants the name. But let's take a look at it if he's asking for the formula. So if we have ethanoic acid, that's the first structure on the left, that's ethanoic acid, and he wants to react it with ethanol. Remember that when they join together, this is what the ester looks like. So if he says draw the ester, that's what you should draw at the bottom there, but he's asking just for the name. Now, how do we name it? We start with the name of the alcohol. The alcohol was ethanol, so the name here will start with ethyl. Now it will be ethyl what? It's ethanoic acid, so it's ethyl ethanoate. Butane dioic acid and ethane diol react together to form a polyester and water. What is the name of this type of polymerization? When I have something with two acids on both ends reacting with something with two alcohols on both ends, that is condensation polymerization. And then he says complete the equation. So he's giving you the structure of butane dioic acid and ethane diol. When we join them, again, remember, we remove OH from the acid and H from the alcohol and so on both ends. So you end up with this structure and two molecules of water. This question is about group 2 elements. Calcium reacts with water to produce calcium hydroxide and hydrogen. Give the word equation. Of course, word equation is the easiest you can get. So calcium plus water gives calcium hydroxide and hydrogen. He's not giving you any chance to think. State two observations that would be made during this reaction. Now, when I put calcium in water, what do we see? Remember, observations means you need to say what we see. So observations are, first of all, it's giving out hydrogen gas, so you see bubbles of gas. Then the solid will dissolve. Describe how a pure dry sample of the insoluble salt barium sulfate could be made from the two solids, sodium sulfate and barium chloride. So he's starting with two solids, sodium sulfate and barium chloride, and he wants to prepare the insoluble salt barium sulfate. Of course, if we add sodium sulfate to barium chloride, we will get barium sulfate. But then the first thing that I need to do is dissolve each solid in water, because I cannot add them as solids. We have to dissolve them in water in separate beakers and then add the two solutions to form the barium sulfate precipitate, which is a white precipitate. Then the precipitate is what I want, so we need to filter the mixture through filter paper and funnel, wash the residue with a few drops of distilled water, and dry between filter paper. Please learn how to explain these and try to include as much of the apparatus as possible. Give an ionic equation for the reaction that occurs. So he's saying, what are we reacting? We're reacting sodium sulfate solution with barium chloride solution. This gives me a precipitate of barium sulfate. The other product would be sodium chloride, and you need to balance. So this is the balanced equation, but he doesn't want that. He wants the ionic. How do we get ionic equation? He said we ionize anything that is aqueous. So the barium sulfate remains the same. Everything else is ionized. Please notice the number of charges on each one is the valency. And if we have Na2SO4, that means I have two sodium ions, not Na2 plus. It's not Na2 plus because, of course, Na is in group 1, so it will lose only one electron. So I have only one positive charge on the sodium, but I have two of them, and so on. And then we cancel whatever is the same on both sides of the arrow, and we end up with the net ionic equation for formation of barium sulfate, which of course will include reaction of barium ions with sulfate ions. When magnesium nitrate is heated, magnesium oxide, nitrogen dioxide, and oxygen form. The equation for the reaction is this. What is the name of this type of reaction? When we start with something and it breaks up into two or more substances, that is called decomposition. Actually, if it is with heat, it is called thermal decomposition. Then the last question says, calculate the total volume in decimeter cubed of gas produced at room temperature when 7.7 grams of magnesium nitrate react. So this was my equation, magnesium nitrate to give magnesium oxide plus NO2 plus O2. He's saying he's starting with 7.7 grams of magnesium nitrate, and he wants to know the total volume of gas. Okay, so first of all, I have information of magnesium nitrate. I need to get the number of moles. Mass over molecular mass of magnesium nitrate. This gives me the number of moles. Then I look at the equation and I relate it to what he's asking about. Please note he's asking for the total volume of gases. So that means from the equation, 2 moles of magnesium nitrate gives a total of how many moles of gas? I have 4 moles of NO2 and 1 mole of O2. That means 2 moles of magnesium nitrate gives 5 moles of gas. So the number of moles that I have will give how many? Do we understand this? 2 moles of magnesium nitrate gives 5 moles of gas. So the 0.052 will give how much? So that is the number of moles of gas. He wants volume. Volume is number of moles times 24. And that's the end of the paper. I hope this was useful to you. And if there is something that you were not able to answer properly, please review it. And thank you for listening.